Now, what are we doing here? Well, we are giving all the critical points and we are graphing. So the first thing we've got to do is realize that we are dealing with an ellipse. Oh, no, excuse me, a hyperbola, because we have one squared term that's positive, one squared term that's negative. So from here, we're going to clean it all up and get 49x squared plus 294x minus 25y squared plus 200y equals the 1,184. Factor out the 49, and 49 times what is 294, boys and girls? 6x, and this is where we're going to complete the square. So half of 6 is 3. 3 squared is 9. Take out the 25, because remember, we have to have a coefficient of 1 in order to complete the square here, both times. So taking out the negative 25, 200 divided by negative 25 is negative 8y. So complete the square there. Half of 8 is 4. 4 squared is 16. But think about, what are we really adding on the left-hand side? We're really adding 49 times 9. And we're really adding negative 25 times 16. So when I go to the right-hand side, I'm going to have 49 times 9 is 441, so plus 441. And then we've got negative 25 times 16. So that is negative 400. So when I add all this together, we're going to have 1184 plus the 441, and then plus the negative 400. Add all that together, we get 1225. Now let's factor both of these. So 49 and then x squared, excuse me, not x squared, but x plus 3 squared minus 25 times y minus 4 squared. And then to get this in standard form, what's the last step? Divide by the 1,225. Because we want this whole thing set equal to 1. So 49 goes into that 25 times. 25 goes into that 49 times. So we have x plus 3 squared over 25 minus y minus 4 squared over 49 equals 1. So from there, this is a hyperbola. A squared is 25. B squared is 49. So A is 5, B is 7, and C squared is A squared plus B squared. So C squared is 74. C is approximate, or we'll just first of all say square root 74. And that is approximately 74 square root. That is 8.6. 8.6. And we need those values in order to graph it from there. Questions to there? Are we good? That's a lot of super big, bad, nasty algebra going on right there, okay? So from there, I'm just going to graph it free-handed because it'll be easier, because the center point is at negative 3, 4, so that's straight from the standard form. So if the center point is there, let's graph it. So back 2, 3, up 1, 2, 3, 4. So there's my center point at negative 3, 4. What is A? A is 5, and that is the distance to a vertex. So 1, 2, 3, 4, 5. That's a vertex. And then in the other direction, 1, 2, 3, 4, 5. That's another vertex. Okay? We'll use B in just a minute. C is 8.6. What is C? The distance to a focus, to the foci in both directions. So we're going to go 8.6. So there's 5, 6, 7, 8.6. That's a focus. And then here's 5, 6, 7, 8.6. That is another focus. So, this, ladies and gentlemen, is a horizontal transverse axis. True? Horizontal transverse axis, because the transverse axis contains the center point, the vertices, and the foci. Now, let's use the B, because remember, 2 times B is the total length of the conjugate axis. And this will allow us to draw the box, if you want to draw the box. So, up 7, 1, 2, 3, 4, 5, 6, 7. That's the top of the box. 1, 2, 3, 4, 5, 6, 7. Down, that's the bottom of the box. So the box is going to go, yes, through the vertices. Make sure I've got it right. Through the vertices. And then through those 2 endpoints of the conjugate axis. So there's your box. Now you can see that the asymptotes, not all the way on the screen, am I? There we go. The asymptotes are going to be going through the corners of those boxes and through the center point. And since this has a horizontal transverse axis, the equation of the asymptotes is y equals k plus or minus b over a times x minus h. So y equals 4 plus or minus b over a, so 7 over 5 x plus 3. So these 2 equations, because it's plus or minus, that represents the 2 asymptotes. Another way to find where the corners of the box are going to be, we can use that slope and say, okay, it's up 7 over 5. That's going to be a point on an asymptote. Up 7, back 5. That's going to be a point on an asymptote. So that's 2 different ways to find the box if you want to draw the box. I usually just draw the asymptotes first. Look at my free-handed work right there. Brilliant. Remember, the asymptotes are dotted lines because they're not technically part of the graph. Here we go. There's the other asymptotes. We have 2 of them, plus 7 over 5 and negative 7 over 5 for their slopes there. And really, once you have the asymptotes drawn in, you can draw the graphs. They don't have to be perfect. Just know that they're going to go through the vertex, and they're going to hug and get all nice and snuggly with those asymptotes, right? They're the mathematical limits on both sides. That's what the graph looks like for number 9. So here's kind of all of it. I do indeed have a class.
Talk to Mr. Mills.
Okay, hold on.
Do your teaching.
Yes, I was recording. So.
Oh. Sorry.